Okay, so as a first step for the final process here, I'm going to be feeding the chips, 250 grams or so of chips. These are mostly big flat packs, sorry, not very obvious, through the grain mill, which I discussed in video 1, which wasn't very good for producing fine powder, but it's actually pretty reasonable at quickly breaking up all these chips into kind of smaller chunks than that. Like these are quite big chips there. I'd say that's probably about 30 or 30, yeah, probably about 30 mil by 30 millimeters, that is. So yeah, so we'll just quickly run these through the grain mill as a start, just to break them up a little bit. You don't actually have to do this, it's just going to speed up the next phase in the ball mill a little bit. So a bit of a burning smell, I'm not sure if that's good. Okay, so that was nice and fast. We'll just let this thing stop. That was nice and fast. Usually I probably wouldn't bother to run things through here. I'm not that impressed by this machine in general. Also don't want to get any grease on my parts, but you know, let's give it a go. So I'll try and show you what we've got now is some relatively broken up bits and pieces. They're still very chunky, so you can see why this wasn't a very good machine to get the super fine dust. But you know, having them broken up to kind of a chunky extent like that's probably a relatively good start for the ball mill. So yeah, I'll just clean this machine out a little bit. So there's still a few bits and pieces stuck in there. And then we'll feed that into the ball mill and get that started. Okay, so the ball mill lives here in the annex in the workshop. As you can see, we've got those 250 grams or so of chips that already had one level of grinding from the grain mill. So we'll chuck them in there. I've got I think that's I've got the 60 millimeter diameter crusher ball. Give that in there, and then I've got the lid with the magnets as described in video number 2, which is the machine that did work, which is the ball mill. So we're just going to put all the magnets on to hold the lid in place and keep the dust inside there where we want it. And then we'll just record the date and time for reference so we know how long it takes. So, ball mill in place. Give it some juice. And there we go. Just before it gets too noisy. It is now about 11 o'clock in the morning on the 31st of August. 11:07, 11:08, 31st of the 8th. So we'll get that started. I expect we're going to need to leave this running about 48 hours. Is really good to get nice fine powder out. And yeah. Okay, so it is now about 20 to 5 on the 1st of September, so it's been a little bit more than a day since we turned this ball mill on with those chips, and as you will see, you know, we're well on our way to turning them into fine powder. There's quite a bit of fine powder already at the back there. The front is still got a few more of the chunks that need breaking up. Turn it on for a little bit, hang on there for a sec. And what you should see, which is something that actually happens to work out quite nice with using the ball mill for this, is that the stuff that still needs breaking up seems to slide easier than the fine powder. So the coarsest stuff actually ends up where the ball falls on them, which is really handy because it means that the coarsest stuff always, gets the ball falling on it. So let's have a quick look there. Okay, so yeah, as I said, we're going to need about 48 hours. We've had about, well, a little bit over 24 hours now, but I've also not had it running the whole time because it can get a bit loud in here when I need to work near it. But we're definitely making progress, so I will check back probably tomorrow evening, and by then I think this is going to be ready for the next process. So yeah, I'll be back tomorrow. Okay, so we've now had the ICs running for about 48 hours in the DIY ball mill here, as shown in the last video, and I'm going to remove the weight first, obviously, because I don't need that smashing around. And this is now fairly fine dust in here. And so obviously the next step is going to be to get it out of the ball mill and get it screened down. So for this you want a reasonable dust mask. This is just one of the standard asbestos type dust masks, and I've also got the shop vac set up here like that, so as I dip the dust in, rather than have the dust settle on everything around me, the shop vac will actually contain most of it. So it's going to be a bit noisy for the next few moments, but just live with it. Also what I'll do is I'll try and work at this kind of angle here, so you'll see what I'm doing most of the time. But yeah, so the next step, we'll get it out, we'll get the dust out of there into there. It's not too tricky. You'll probably figure this out by yourself. Flip it upside down. Okay, so as you can see there, we've got, I'll try and get this, we've got this very fine powder that moves very freely. And what I'm going to do now, I'm going to be doing this with the vac on, so I'll describe first and then I'll do it. But I'm just going to transfer this stuff into a smaller container, and then I'm going to use my fine flour sieve to sieve the material back into this container. And I'll discard, as you can see here, this is my discard pile, all of the bits of copper and heat sinks and any bits of chip that didn't actually manage to get completely crushed up to powder will go back into this one. Yeah, so I'll quickly do that, and then I'll be back to describe the next step. Okay, so the previous part of the video, if I could figure it all out, was probably played at about double or triple speed, just so you didn't have to wait too long while I do something boring. But you can see now what we're left with. It's kind of hard to tip it because it runs very finely now, almost like cement powder, for those of you who are familiar with cement powder. And yeah, so that's where we are now. So we've got relatively fine powder. The sieve has holes that are about 0.5 millimeter, so so it's a 500 micron sieve. You can go even smaller than this, and you'll see later on why it would actually be quite nice to have like a 150 micron sieve as well. But for now, that's what I've got, so that's what I've used. You can see here the stuff in the discard pile. I'm just going to tilt the camera down a little bit so you can see there. We've got some little bits of chip, mostly the thicker ones. They don't seem to break up as easily, and lots of metallic pins. And so I can see a few copper pins, I can see a few iron pins, lots of heat spreaders, bits of copper heat spreaders and things like that. So yeah, that's you know, you could either run that stuff again. I don't usually bother too much. I find that I get enough gold out of the stuff that I've got already. But yeah, that's up to you. Anyway, okay, I'm just going to turn off for a moment and set up the magnetic separator as described in the previous video, and then I'll run the fine powder through the magnetic separator next. Okay, so here we have the magnetic separator set up as per like how I described it in part 2 of this 3-part series. So this might be a little bit boring as well, so I might forward the next bit, but what I'm going to do now is I'm going to use my spoon, I'm going to use my fine powder, scoop it into the funnel slowly. All of this has obviously been set up to be kind of level. I don't know if it really matters much, but I always set it up to be level. And yeah, so it's going to get a bit noisy while the video is hopefully going to be in fast forward mode, because once again I turn the shop vac on just to suck up any of the excess dust that obviously Keith isn't going to be happy, because fine dust isn't very good for vacuum cleaners, but that's why you use a crappy old shop vac for this part. Okay, let's and then after I'm finished with this, I'll just show you what actually got separated out, but there should be a fair bit of magnetic stuff, seeing as this was mixed ICs. Okay, so next we are going to use the little hammer to tap the plastic tube, so that any dust that is not magnetic but is getting caught up in the pins will drop down into the little bucket down the bottom, which is over there. And what I will do then is I will swap containers over, and I'll run all the stuff in the bucket through again, because the more magnetic stuff you can take out at this part, the better. And then all that magnetic stuff that comes out will just go into my rust bucket out the back of the house. So yeah, here we go. Okay, so not much reason for you guys to watch me run all this stuff again for the next minute or so. Yep, so we'll be back when we get to the next stage of the process here. But at the moment we've got this powder. It looks a bit clumpy, but all of that is kind of talcum powder consistency. There are a fair bit of, you can see, I don't know if you'll be able to see it on the camera, there's still a fair bit of copper pins in there, but copper pins will get dealt with later, no problem. So I'm just going to run all this stuff through the whole magnetic system again, and then I'll come back and show you guys the results. Okay, so I've finished running the fine IC powder through the magnetic separator a couple of times now, and just to show you guys the results, I'm going to pull away the bar. Look at that. So the nice thing here, obviously, for anyone who's actually done this, is instead of spending, let me put it on that side, quite a long time trying to separate this stuff using a, see all this iron pins there, you spend quite a long time trying to separate this stuff once you get all the powder wet, and I'm pretty sure you take a lot of your gold with the iron, because when it's wet it all kind of sticks together, and if you put a magnet in there it's going to trap some of the particles, whereas when you're catching them while they're kind of weightless, like when they're falling down the tube, yeah, you end up with pretty good results. And so you'll see I've got a collection here, there, we're just going to add that to the collection, and that can basically go into the rust bucket and can rust away, and then eventually one day when I'm old I might go through and see if there's any gold to be recovered out of that. But I did pan some of it and I couldn't see a single speck of gold, so I'm pretty sure my magnetic separator is working as expected. So on the other side, let me just grab that. We now have our fine powder. Still plenty of little, you might not be able to, oh, you could see them, there's little shiny bits in there, there's little copper pins in there, so there we go. But what's left now, it's not magnetic, we're going to deal with it in the next couple of phases of this project. So yeah, that's the fine powder we want, and yeah, looking great. So I'll be back soonish when I'm going on to the next stage of this video. I'll be back, see ya. Okay, so nice Saturday morning here in Auckland. It's a little bit rainy outside, which is great for getting these videos done. So I thought we might take a little bit of a break from the gold recovery and do some cake baking. Just kidding. Okay, so what we've got at the moment is a tub here full of the powder that came from the ball mill that has gone through the 500 micron sieve, and after that it has been treated with my vertical magnetic separator. It's kind of lying back here, it's the one I discussed in the video about the gold machines that work. And now the powder we're looking at here is actually not from the single 250 grams or so of chips that I showed you guys putting in, but this is actually 2 runs of chips. So this powder probably started as about half a kilogram, or roughly 1 pound of chips. And just so we're all on the same page, what I'll quickly do here for you, I can reorient the camera, is zero off the scale sort of. We'll just quickly see what we're left with. So we're looking at the scale in grams there. Just see what, so after we took out the magnetic parts, and so first we took out some of the larger parts here that didn't get crushed up by the ball mill. The black bits in there will still obviously contain a little bit of gold in terms of gold bond wires, and so what I will still do is at some point I'll pick those out and chuck them into a future batch. And the magnetic stuff that got caught is in my magnetic bucket here. You can see right there, there we go, you can kind of see all the steel pins. Obviously these will also still contain a little bit of gold, but not it's not the bulk of the gold. So let's quickly weigh up what I'm left with, just so everyone playing along at home is aware. Just dump it in. I should have probably turned on a little bit of extraction here. It's not too much dust. It's okay. Okay, so we're left with about 355 grams of really nice, super fine powder. I keep on calling it dust. Sorry, English is not my first language, but it's powder, and it's so fine that you'll see if I press it, you end up with smooth. You end up with smooth press marks in it. So we really are talking, I don't know, cement or talcum powder or something like that. Okay, now let's get back to the cake baking. So we're pretty much ready to go now. So as I was saying before, one of the biggest problems of dealing with this superfine powder, which is now broken up epoxy rather than the ash that you would normally get with incineration, is that it is really difficult to get this stuff wet. If I filled up my container with water and just put this stuff in and use the spoon to try and mix it, you can't actually, it forms clumps almost like flour does in water, and it is very, very difficult to get this stuff hydrated, I guess would be the best term. I'm not sure what the best term is to describe that, but the key to getting it wet first, so we're not going to wash this material in the same way that I washed it when I was doing the incineration process. You can take my word for it when I say that it doesn't work. You wash away at least half your gold if you're lucky. It's only half. The reason I think that is because the epoxy, when it's this fine, the same as the ash when it's this fine, the epoxy is much denser. You haven't actually burned it and got rid of the carbon chains, and so the epoxy weighs a lot more. Like this is quite a heavy, 400 grams or something for quite a small amount of epoxy, and I think that's the reason why it doesn't work very well to separate it from your gold by just washing it in a bucket and tipping out the stuff that doesn't sink like you can with ash. So the first step, without wasting too much more time, is we're going to use a bucket. We're going to use some, what's this stuff called again? It is called Rinse-Aid. We're going to use some Rinse-Aid. This is just what I've picked up from the local supermarket. You don't want to use dishwashing liquid or soap at this, or I don't want to at this point, because it makes a lot of froth, bubbles, and that froth actually also traps a lot of this fine powder. So if you can keep the frothing down, that's a good idea. So we'll start off by putting a little bit of water in here. If you're kind of familiar with what we're doing here, then you might want to, this is pretty piddly, sorry, you might want to skip past this bit, but what we're going to do, obviously, put some water in, start adding our flour into our cake mix nice and slowly, and I'm going to use the kitchen mixer thing to get the flour, I should stop on the powder, to get our fine powder mixed into the, to hydrate it into the water. So we're going to give it a bit of that. Now I'll just quickly demonstrate for you. I'm not going to put too much more water in for now. Oops. Let me see if I zoom in on that a bit. I just want to show you what happens when you put this stuff into the water. It's so, you can see it just instantly floats on the water, and I'll try and keep the dust down a little bit. What I might do quickly, I'll just grab my spoon and you see, if I try and mix it into the water like that, you just end up with this, like you can see right through, there's none of it is actually, when I do that, you can see through to the bottom of the bowl, none of it's getting mixed up in the water. And so rather, if I put the mixer into it right now, all I'm going to do is I'm going to end up with a bunch of dust. It's just going to kick up dust. So what we'll do is we'll just give it a generous amount of Rinse-Aid to start, and immediately you'll see some of the stuff there is actually falling through into the water, and so you can see the water is, or the solution there is changing color. So I've tried this with a spoon. It takes a very long time with a spoon to get that stuff hydrated, whatever the right term is there. So we're just going to put the kitchen blend mixer on slow and just work our way through. Okay, I'm going to turn it off here. Keep on doing this, and for a little while. I might pop back later if there's something more to tell. Otherwise, I'm just going to add in more powder slowly, and probably add in some more water and get all that stuff hydrated. Okay, I'll be back. Okay, so I've got most of my mix there. Let's spray all this stuff down. I've got most of my mix there pretty well hydrated. I think all the clumpy bits are broken up, and I've used quite a lot of the rinse aid, like 3 or 4 really good squirts in there, and you'll see there's very little foaming there. I can kind of spray it down with the bottle, and when you spray it down with the bottle and you don't see any more floating bits, that's when you know that it's all pretty much ready to go. So this is actually a much bigger deal than what it might appear to you to be at this point. So I've gone through many iterations of trying to make this incineration-free process work properly, and this system with the rinse aid and the mixer, combined with the sieving that we've done, combined with what I'm going to be showing you next, is crucial. I have done hundreds of grams to maybe kilograms of chips now, where I've ended up with only 25 to 50% of the gold that I was supposed to get, because I didn't do these steps in this order. So trust me on this. You know, I highly recommend you try and do any other system that you might think about, but this is the bit that I found that works. Okay, I'll just going to take some time to set up the next process, and then I will be back. Okay guys, welcome back. I've just set up everything here, and what you're actually looking at the moment is the single biggest secret to gold recovery without incineration that I've found so far. I went through the process of getting the powder, and I went through figured out how to get all the powder wet so it's all hydrated, and then I started panning the powder, because I'd seen a lot of videos of guys panning the powder and ending up with the gold bond wires at the end, and every single time I was missing a lot of gold. Like you know, we're talking, I was only getting 25 to 50% of the gold that I had come to expect after incineration by doing it the panning way and using the bucket washing way, probably losing even more gold. And as I said before, I think the reason for that was that the density difference between ash and gold, even in that fine state, was much better than the density difference between the powder of the epoxy powder and the gold. Anyway, so what you're looking at, a lot of you may already be familiar with, some of you may not be familiar with. This thing on my right is called a blue bowl. This is something that I made myself by just getting a plastic tub and gluing a upside down funnel. So I cut off an upside down funnel, glued it down, obviously cut a big hole in the bottom of the plastic tub, and it's got a water inlet on the side here, which what I'll do is I'll just get the camera off the tripod and we'll have a look. It's got a water inlet on the side there that comes from the pump in that container there. It pumps it all the way in, and there's got a little valve here to control the amount of water flow. It makes the water spin in this direction. The water rises up, and the water and the lighter materials will work their way up the cone. So they go up, 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 and they fall down the hole into, I've got a catch bucket below here, and the catch bucket has got some, let's go to the other side, it's got some holes drilled into it about halfway up, where the water will fall out of the catch bucket into the discard bucket, or discharge bucket, I'm not sure what you call this one, or the container. And the idea here is that if if I were to screw up the water flow and I'm getting too much flow and I'm losing some gold down the center, I am still going to catch the gold will fall into this bucket. It'll sink down to the bottom. So this is just gravity separating again in this bucket here, and then anything that makes it past that lands in my discharge container here, and there's the outflow for the discharge container. You'll see is about 2 inches up from the bottom, so that gives me a second chance to catch anything that might be so tiny that it makes it through this bucket. And then the discharge, because we haven't incinerated everything, and because we're mostly just getting rid of epoxy dust, I've got the discharge container just going to the what we in New Zealand call a metal driveway, but it's just gravel or rocks that form our couple of 100 meters of driveway. And so fairly safe. You know, you might be discharging a tiny bit of metal, but there's nothing in solution really. So metals in metallic form are fairly safe. As soon as they get into solution, they can be quite poisonous to plants and animals. But yeah, let me get this thing turned on, and then just going to show you what happens. So the other thing is, you'll see I've got some door wedges on 2 of the corners. The idea with this thing is that your bowl has to be set up very level in all directions. So if now, what I can say is that I built this because the real blue bowl, the real product in New Zealand, is about $200, which I thought for a plastic molded thing, $200 is a little bit on the stiff side. Now that I know how well it actually works, I would spend that $200 in a heartbeat. I think there is no one that's doing any kind of gold recovery that should not own and be quite skilled at operating one of these things. It is the single best way of separating fine gold from everything else that I have ever seen. It is almost magic. So let me quickly, what we'll do, so we'll get us back on the tripod here, turn on the pump. Okay, so the pump is on. We'll open the valve up a little bit. So you can see on that side, you can see the water start. Zoom in there for you. It's kind of hard to see you can't really see the water rotating much, but the water is starting to build up a bit of rotation. And so I think for the rest of this video, or the rest of this segment of the video, what I'll do is I'll focus in on the blue bowl, and this is not a process that you can quite leave to just do its own thing and walk away. I found that the key here is continuously, like every couple of minutes, adjusting the water flow so that what's left in the bowl does exactly what you think it should do, which is get rid of the light stuff, which is generally black, and leave the metallic pins and the gold in there. And yeah, so what I'm going to do quickly is I'm going to grab the container with the wetted stuff that we've got, and I'm going to start showing you how we're going to deal with that stuff in the blue bowl. So I've got the water speed set fairly slow. This is much slower than what they usually tell you to do when you're separating black sand from gold, because the gold that we are separating is way smaller than stuff that the normal kind of gold panning guys, prospectors, those guys are actually dealing with. You know, our gold is microscopic, so you deal with it a bit different. One of the things I didn't mention is there's a very good reason why I have a fresh water supply there, rather than just recirculating the water from the bucket or from the container that the blue bowl is in. And the reason for that is, as I said before, it is crucial that you are always able to see what the blue bowl is doing. And if you recirculate the water that we're going to put in, like you'll see when I put it in, you can't see anything into it. That epoxy dust is just going to fill up all of the water. So I recommend having a fresh water supply of some description, and just except that you are going to get rid of your waste straight away rather than recirculate. Overall, we're not going to use that much water. It might be 50 litres or 100 litres or something of water for the half a kilogram of chips I've got there, which in New Zealand water doesn't really cost anything, so just falls out of the sky all the time. So not a real problem for us. But yeah, I'll be back in a minute or two and start showing you how we're going to deal with the dust we've got. Okay, so our container with our wetted powder, I should stop saying dust, it's powder, has had a little bit of time to settle, and apart from a few bubbles at the top, everything appears to have actually wetted quite well in this batch. So the very first thing to do is with the blue bowl, you should go and look up, there's loads of videos describing how to run a blue bowl, but with the blue bowl, one of the things you do is you feed the material in at the far edges, and you let it work its way to the center. So what I'm going to do is I'm just going to start slowly, because this is a slow process. This is something where you really have to pay attention. I'm just going to feed the material in slowly, so we'll just give that a little bit of a run there. Now you'll see what I mean about not being able to see anything through the water. But on the plus side, what you can actually see now fairly easily is you can see the motion of the water. So you can see I haven't got it set very fast. The closer we get to only having gold in there, the faster you will find you can set it, and you won't lose gold. But at this point, while there is so much material suspended in the water, it's you want to set it quite slow. Even though this whole process is probably going to take me about an hour, obviously I'm going to try and cut out the bits where nothing's really happening for you guys, and then just kind of focus in when there is something I think worth telling. Even though it takes an hour, this is an incredibly enjoyable machine to sit and watch. I can quite happily sit here for an hour and watch it do its work. Not quite when it's like this, when you can't see what's actually happening, but when you actually get to the point of being able to see through the dirt and see in the bottom how it's moving all the light stuff around while the heavy stuff stays put. It is absolute magic, and I hope I get some nice bits I can show you guys in this video of how that's happening. So I'm going to just feed in the rest of the watery material here. You'll see underneath there's quite a lot of the wetted powder, which I won't worry about now, but I'll feed in the rest of the watery material, and then I'll come back to you guys when I'm moving along to spooning in the denser stuff that's at the bottom of my container at the moment. Okay, so I'll be back a little bit later. Okay, so I have added in all of the watery stuff in my bowl here, and you'll see what's left now looks like that. It's we'll call this the concentrate, I guess, because this is going to contain our gold at this point. You'll see the bowl has cleared itself, and apart from possibly a little bit of heavy stuff, I don't think there's going to be any gold in there yet, but there's a few, like all of the really light stuff in suspension has cleared itself, and it's gone down. It's had a time to settle twice, and then it's run out. So now I'm going to start slowly feeding my blue bowl from the edges with this concentrate from a spoon. I've got it set fairly slow right now because I want to give the heavy stuff a chance to settle around the outside, and you can see underneath my spoon here when it clears up a bit it's already settled a little bit. So we'll give it a couple of spoonfuls just so initially you guys can see what's going on. And then what I'm going to do is I'm just going to turn up the water flow a little bit because we're a little bit slow right there. This is definitely a game where you really need to watch. Like you're gonna build up a bit of experience with this, and you're going to learn to read the water flow and read what's happening on your cone in the center, and understand what's happening with your gold. So there you go. Now I might cut out a little bit here just until the cloudiness and the water subsides, and then I will really zoom in and fiddle with the water flow a little bit so you guys can see what happens to the lines, or the concentrate that's sitting on the bottom there. Okay, so I'll be back when it's cleared itself up a little bit. Okay, so getting my camera to zoom, to focus on the underside of the water is proving to be a little bit difficult. But this is the first couple of spoons that I've put in, and you guys can clearly see there, if you look at the inside closer to where the cone is, you can actually see the light black material moving towards the center of the cone, and you can see on the trailing edge there you've already got some color differences. Now a lot of what you're seeing there is just going to be copper and pins and stuff like that, but you can clearly see how the blue bowl is getting rid of all the lighter stuff while leaving the heavier stuff in place. This is the last of the fingers of the first two scoops to start moving. If we look on the opposite side through the water, let me try and get my angle better with the light reflection and stuff. You can see some pins that were left, and you can actually see a faint trail there, and that trail already is going to contain a little bit of gold. Eventually, let's look at this. This is the see if it wants to focus. There we go. So you can see the light stuff moving off. This is actually quite a nice way, and you can actually see it there, the light stuff in the middle walking up the funnel and getting washed off, while the heavy stuff, which is on the trailing edge there, stays in place. So I'll just see if we can keep that focused there for a little bit longer. You watch that little piece of light fluff there. You can actually see the light stuff walking up onto the funnel and getting washed away. Heavier stuff like that, and the gold obviously as well, not being affected by this, which is just an absolutely fantastic invention. And as I said before, obviously I have no interest in the company, but you can spend money on a blue bowl. It is a very, very, very useful piece of kit. So what I'm going to do now is I'm just going to keep on feeding the bowl. So it probably took about 5 minutes to go from feeding those 2 spoons in to having gotten rid of all the light stuff like this. I'd feed it a little bit quicker than this. As soon as I can kind of see through the water, as soon as it clears up, I tend to feed some more material into it. So water speed at this stage is still quite slow, so we're really only washing away the lightest of stuff. Later on, you'll be able to separate even things like the copper pins like that from the gold powder. The gold powder is actually still more dense, even though it's so much smaller than those copper pins. But I'll keep on feeding this thing for a while and be back in a little bit. Just to give you an idea, it's now about 10 to 1 in the afternoon or so, so we'll just see how long it takes to get this all done. Okay, so I've now fed in, as you will see there, probably, might not be very obvious to you, but about a quarter to a third of the material that I've got to feed through today, and washed away most of the light stuff in there. So there's quite a lot of copper pins now, and almost guaranteed to be a little bit of gold as well at this point already in there. But you'll see now that there's some clumps forming, like there's a little clump there and there's a little clump there, and those clumps I find don't wash very well when you've got this many copper pins that are kind of distributed like this. Now, for the eagle-eared viewers, you will remember earlier on I said it would have been quite nice if I had some thinner screens or meshes for my sieve than what I've got. The 500 micron one is at this point, it allows the bond wires and the copper pins to go through. But there's a relatively simple fix that is a good thing to do at this point, and that is you just turn the water so it's almost not flowing, only just going, probably like that. And then what you can do is just grab a snuffer bottle, And what I'm doing, if it's not, I'm just going to move all the material that's accumulated so far to the outside edge of my bowl. And what this also does, as you'll see, is it frees up some of that fine stuff that's still contained. I did actually just see a little bit of gold there. I might, if I can do that again. When you push the material around with the snuffer bottle, the gold being so much denser than everything else tends to lag behind. So you can, at this point, you can already, how can I show you this without these bloody lights in the way? Right there, can we see it? No, because the tip of the snuffer bottle becomes invisible. Pretty much in the middle of your screen there, just move it around there. There's actually a little bit of gold powder right there already, so there's definitely some gold powder already collecting. It will be much more obvious later on when I start adjusting the speed in such a way that I'm separating the gold powder from the copper pins, which we can also do with this. So we'll go back to time lapse again now. If you've seen a bunch of time lapse pictures, then it means the time lapse thing worked out okay, and you could actually see what it was doing. Now I might have accidentally sucked up some little bits of gold powder with my snuffer bottle, but it's not a big deal. So I've moved everything to the outside. Sorry about the light reflection, it's kind of hard to deal with that. Moved all the material to the outside, so I'm just going to set up now and just keep on feeding this. It's only like been 10 minutes, maybe 12 minutes or something since the last time that I videoed, and I've already gone through about maybe a third of the material I had. So it's not actually that slow, it's actually a fairly fast process, and I've gotten rid of, you know, you can see what I'm left with. I'm left with gold and copper and heavy stuff, and I've gotten rid of 99% already of the epoxy and the plastic that was in here. So yeah, I'll just keep on feeding and come back when there's something interesting. Okay guys, so I have run, just grab that, all of the material from the original bowl. It's all gone through the blue bowl, and as you can see, we've got rid of 99% of the crap, the black stuff from it. I know some of you guys must be thinking at this point, man, he must have washed quite a lot of gold away. So you're just going to have to trust me at this point when I say not really. And I think the water is actually going to stay clear enough now that I'll just video for a little bit and I'll just show you what I'm going to do now. So we've still got a couple of ridges there where we kind of got black stuff clumping, so there's not much actually flowing at this point. The water flow is actually still very slow compared to how most people run the blue bowl. Just for your reference, it is now 1:45, so we haven't really even been at this for an hour yet, and we've already run most of the material. So it's actually not a particularly slow process, and if you've just got a sip of a beer or something, just enjoy yourself and enjoy how magical this bowl is. And okay, so we'll just video and I'll just talk as I go. We're just gonna sit here, turn off that water, so we'll slow down the water flow just a little bit more. We want hardly any water flow while we're busy knocking stuff up into suspension in the water, because obviously we don't want to knock little tiny bits of microscopic gold up and actually get them to leave the bowl. So just what I did before, we're just going to move move everything to the outside edge. Now what's really nice is, this might not be that obvious to you guys, but over here I can see as I'm pushing it, the black stuff moves quite quickly, but that yellow stuff that's really fine is quite hard to push out to the edge. So that's pure gold right there. just keep on pushing everything out to the edge quickly. Now, one of the nice things that happens that's not that obvious when I push stuff to the edge is the black stuff gets pushed onto the outside ridge of the because the black stuff kind of goes into suspension easier because it's much lighter. So I'm pushing it up onto that outer ridge, which then when I turn the water on again, it's going to very easily separate the black stuff and push it towards the center, which I'll show you this time around with the video going rather than just the time lapse. I think the time lapse has come out okay, so you guys have probably been watching that for a minute or two now. Even though for me that was 30 minutes or so of time lapse. Just fill up. So I'm just filling up my squirt container with clean water rather than sucking up anything that's in suspension. Just going to keep on doing that. Now, I think that's probably good enough. We'll just wait for that to settle just a little bit and we'll just double check it. Yeah, so I'm going to turn on the water flow a little bit. So we're going to go back to kind of normal water flow. Still quite slow water flow at this point. Just because it's going to be, you guys should be able to see very nicely what the light material is going to migrate from the outside to the inside relatively quickly. And actually at this stage I can already see quite a lot of gold that I've kind of blown up with my bottle sitting on this outside edge. You guys might be able to see it, I'm not quite sure. Okay, so we need a little bit more water flow to make that stuff start walking. So we'll just give it a little bit more. The water flow is critical. You want to give the water enough energy to carry away the light stuff, but not enough energy to carry away the gold. Now if you look all around the outside of our clump, you can clearly see the gold all along the edge. The gold is the most dense stuff that we've got in there, and now you can clearly see how all the black stuff is converging on the center there. This is really fantastic to watch. I really enjoy the blue ball. It's very entertaining. I think we can give the we'll leave the water there. We can give it a little bit more speed, but making it go a bit slower gives you guys a little bit more of a view of what's actually happening there. So you'll see the spirals forming and then go towards the center. Unfortunately, with the black cone, it's not very obvious with the black material when it's going over the cone. But you can clearly see how it's pulling all the black material from the outside inwards at this point. I'm going to give it a little bit more flow. I think we need a little bit more to get the water energy where I want it to be. So now you can see the black stuff really moving, especially around this side here. There we go. Okay guys, hopefully that time lapse went well. As you can see, we've now got rid of pretty much all of the black material, the epoxy from our machined and sifted chips, and we're left mostly with copper pins. I think I had to think about it, and I think the dull grey stuff that we're seeing, they're quite shiny as they're walking up the cone. And I think that what they are actually are they're bits of smashed up dye, so they're actually silica. But I thought maybe at this point, before I move along, I'll try and zoom in because I really want to show you guys some gold at this point. So if you look all along that edge there, that's all gold. The color might not be quite right on the camera with the white balance and things, but it's, I mean, all along all these things telling me that it's gold, and especially if you look like over there-ish, things telling me that that's gold is it's right at the trailing edges. So the water was flowing clockwise, so we're looking at this thing from the top, the water was flowing clockwise, and so we expect the gold to collect at the trailing edges. And pretty much if you look at the trailing edges, of any of these bits of like clumps of pins, there is gold right there, some gold right there. You know, you can pick any of them. All along the trailing outside edges is gold. So what I'm going to do next, oops, let's just get this thing zooming out a little bit. Sorry, the zoom's pretty slow on this camera. What I'm going to do next is I'm going to wash all of this stuff into a 500 milliliter clean beaker, and we're going to move on to the chemical processing of the material in here. But yeah, I look forward to showing it to you in the beaker, because you'll see how dramatically we've reduced the volume. You know, we're left only with the very dense stuff at this point. So yeah, say one more time how awesome the blue bowl is, and it's just the best tool ever. So I'll be back a little bit later when we're start with the chemical processing. Okay guys, so I've washed the material from the blue bowl into a 500 ml beaker, and you'll see it's only just covering the bottom, which is pretty fantastic considering we started with about 500 ml probably of that black powder. And most of you will not be terribly excited by what you're seeing there. You can see a few copper pins, some of them with a little bit of tin on them, and absolutely no gold. There's one little piece of big copper in there that I'll actually just pull out by hand. But if we give it a magic swirl like that, we'll just let the water calm, and we look at the bottom. We just need to get somewhere where we can see the color. See, nope, that's not going to work. How are we going to do this for you guys? Maybe that will work there. Anyway, very difficult to see, but truckloads of gold. So all the gold is, I mean, it's really fine. You can see it on the edges there. Really, really fine stuff. But the gold is in there, which is great. So now we will move along, and we're going to start chemically treating this stuff to end up with just gold. Okay guys, so we're now working in the fume hood, and we've got our gloves on, and we've got our eye protection on. And the first thing we're going to do with our little mixture of copper, tin, lead, possibly maybe a little tiny bit of iron still, maybe some silver, definitely guaranteed some gold, is that we are going to treat it with hydrochloric acid. The reason that we're going to start, get rid of the up there, the reason that we're going to start with hydrochloric acid, just open that up in there because it can fume a little bit sometimes, give that a little bit of hydrochloric, and obviously, sorry, working in your way there, obviously it's on the hot plate, and we're going to cover it with a watch glass. The reason we're starting with hydrochloric, and I can already see a reaction, which is fantastic. Like you're always hoping something will happen when you add stuff in. The reason we're starting with hydrochloric is the tin. Tin is a pain in the ass, as I'm sure if most of you are getting to this point, you've probably already read and seen videos and tried for yourself and found out that tin is actually what we use to make colloidal gold from gold in solution. That's basically when we're testing with stannous chloride, what we're doing is we're turning gold in solution into colloidal gold. So we've got a little bit of hydrochloric in there. I know when I was beginning with all this, I always cared about the concentrations of stuff. I think that is 33% hydrochloric acid, which is basically just standard off-the-shelf swimming pool acid. If you can buy 24% from the hardware store, that's perfectly fine. The concentration actually doesn't matter that much. To dissolve tin though, you need the whole thing to be hot. In Hoke's book she talks about boiling it. There's no need to boil your hydrochloric to remove the tin. Just warming it up to, you know, somewhere between 60 degrees C and 80 degrees C is absolutely fine. It just takes a little while longer to dissolve the tin, but that's no big problem. So I'm just going to leave this now running until the reaction stops. I'm sure I've got enough hydrochloric in there to dissolve the little bit of tin that might be in there, and then I'll be back and talk about what we are going to do next. So I will see you guys soon. Okay, so our reaction with the tin with the hydrochloric acid in here has now all but stopped, and so the next step, there's obviously still a lot of copper pins and all the stuff that doesn't react with hydrochloric acid is still left in there. You'll see I added some boiling water to dissolve some of the tin chloride, but now we want to get rid of the hydrochloric acid, and there are a couple of ways of doing this. One of them, which I'm going to do, which is not the best way, is to just rinse the material out many times using boiling water, and then I will be using some litmus paper like that to check the pH of the solution, until it basically stays neutral when I add water to it, and that means that I've got rid of the vast majority of the hydrochloric acid. So just to give you a indication of what we're looking at, on your left there, pH 1, 2, 3, 4, that's going to be acidic. I expect the solution at the moment should be about pH 1, and so I will put a little bit of litmus paper in there for you just to demonstrate this. Okay, there you go. Really dark stain. That's pH is probably even below 1, which is why it's got that kind of purpley color, which is kind of past the orange part. So yeah, what I'm going to do now, I'm just going to boil water and keep on rinsing this out, and I will show you maybe after 2 or 3 rinses what the litmus paper looks like, and yeah, and then we'll deal with the next phase of this. Okay, so we've done 2 or 3 rinses or so there, nothing too major yet, but you'll see now when I put the litmus paper in, we've only got a very mild reaction. To my eye, that looks even less of a reaction than it does on there. We're still probably a little bit acidic, but we're getting to the pH 4 maybe kind of range now. So we're definitely getting there. A few more rinses and that'll be completely neutral. Now I can't remember whether I 2 minutes ago mentioned what the alternative to the rinsing was. The alternative is to rinse it a few times, but then you actually incinerate the material, which does a really good job of getting rid of all the hydrochloric. But me being a lazy guy at the moment, I'm just going to keep on rinsing, even if I have to put a liter of boiling water through there. It doesn't matter, because I'll just evaporate it off to next to nothing anyway. So it's not really creating massive amounts of waste in my waste stream, so I'll just keep on rinsing until it stays neutral, and then we'll be back. Okay, 5 or 6 rinses later, and as you will hopefully see when I put a bit of litmus paper in there, we are, if I can get this focusing to happen, sorry, we are definitely in the pH 7 range, even possibly approaching pH 8, but it's definitely not super acidic anymore. Now, I don't think I mentioned the actual reason we're going to all this trouble to keep on rinsing this. The reason is that we are going to use nitric acid next to get rid of all the copper base metal from our concentrate there. And if we leave traces of hydrochloric there, it will dissolve trace amounts of gold into solution. Probably not going to be that big a deal, because what will happen is that gold will actually cement out on the copper, once all the hydrochloric is used up anyway. But if you can get rid of it you know, with a little bit of water rinsing, it's so easy that you might as well do it. So I'm going to rinse this just a few more times to be safe, and then we will hit it with the nitric acid. Okay guys, so we have now rinsed out what was left of the I have rinsed out what was left of the hydrochloric acid there, and the next step is going to be to get rid of the remaining copper, and we're going to get rid of the remaining copper by adding nitric acid. So what I've got in there at the moment is about 100 milliliters of distilled water, and the reason we use distilled water here is because once again we're trying to avoid chlorine in there forming weak aqua regia. So yeah, so I've got a pipette, one of those disposable ones. So every shot that I give this is roughly 2 milliliters of, or maybe 1.5 or so milliliters of nitric acid. So yeah, you'll see immediate vigorous reaction. That's because the let me just turn the temperature down a little bit. Oh, sorry. That's because the water was already heated to about 80 degrees or so. So we'll go 1, 2, probably give it about 3, maybe 5 or 6 shots at the moment, just to start off with. It's going to need more than that to get rid of that amount of copper, but what we want to do here, because nitric acid is relatively expensive, is we don't want to use any more than we have to get rid of that copper. And so what I'm going to do is I'm going to give it, say, 5 shots now, let those completely completely exhaust itself, and then once the reaction stops, I will come back and I'll keep on, so let me just put the lid on there, I'll keep on adding more nitric acid until basically all of the remaining base metals are gone. Now, as you would have seen in every other video, the brown gas forming there is toxic, so fume hood is great, outside is okay, outside with a fan blowing as well is slightly better. Okay, so it's probably been about 5 or 6 hours since the last time we had a look at this solution, and at this point all of the base metals appear to have been dissolved by the nitric acid. In total it looks like I've used about 35 milliliters of nitric acid, which is in the realms of possibility for the amount of copper that was there. So let me just have a look here, give it a bit of a shake. We do have a few floaters there, but I'm not sure what they are. They look like leftovers from the digested pins. I think at this point, I think we have already overdosed on the nitric a little bit, but I'm going to give it 1 more milliliter or so, just to make sure. No, there doesn't appear to be any reaction at all to that last milliliter of nitric, so that's good. That's pretty much in line with what we were expecting. So the next phase of this is that I am going to wash out the nitric very much the same way that I initially washed out that initial hydrochloric leach. Apart from that, you don't have to be quite as you don't have to get rid of all the nitric like you had to get rid of all the hydrochloric. You can just give it 2 or 3 washes. You're basically just cleaning up the material that's left and getting rid of as much of that copper nitrate as possible, because you don't really want that in your final aqua regia. So yeah, I'm just going to be boiling the kettle now and washing what's left there clean, and I'll come back when I've done that. Okay, so now we have all of the nitric acid washed out there. Still a little bit of material left in the bottom, which is now going to be hopefully just gold or just precious metals and probably whatever plastic I couldn't get rid of earlier. Hopefully with the hydrochloric treatment and then the nitric treatment, we should have taken care of most of the base metals. So the next phase is I've warmed up a bit of water there, that's distilled water that it's sitting in, and I'm going to add in some hydrochloric acid first now. I'll probably give it about 50 mils or so of hydrochloric acid. If we're lucky, there might be a little bit of a reaction there if there's still some nitric left, and it might turn a little bit yellow. If we're not lucky, then I might have to add some more nitric before we'll see anything happen, but let's see what happens. So hydrochloric going in. Okay, and you will notice we are getting a yellow color, which is relatively good sign. We'll put the watch glass back on top. We'll turn on the heat because we want, when we're making our aqua regia, we really want the reaction to be sitting in the 60 degrees Celsius to 80 degrees Celsius kind of range. And yeah, not that much happening there. I did do a few rinses, so I probably got rid of about 99.9 something % of the nitric acid that was present already. And so I'm just going to let this warm up a little bit, and then I will start adding in nitric acid in very, very small increments. So it looks like, yeah, it looks like we've stabilized at about 60 something degrees Celsius there. Sorry about blocking the view. I have to use my left hand to hold the bottle while I take off the lid for the nitric acid. So let's give it half a milliliter or so of nitric acid first. See if anything wants to happen at all there. Okay, so it's only really been a minute and a half since my last cut, and the temperature got up to about 75 degrees Celsius, and now you can clearly see that there's a little bit of a reaction happening there. I haven't put truckloads of nitric in, so the reaction isn't particularly violent at this point, but as you all should know at this stage, we don't want to overdose on the nitric acid. So I am going to try and follow my own advice and put small amounts in, not very often, to just while the reaction is happening. But yeah, so as you can see there, we are definitely getting a decent amount of reaction now. Unfortunately, on your angle, you guys are kind of looking across the top of it, but if you look from higher up, there's quite a bit of very fine fizzing and bubbling going on, and the color of my solution is okay. It's not the perfect golden color that you get when you dissolve, you know, gold, pure gold, but looking pretty good. So yeah, scratch my earlier advice. Basically, you want to be up above about 75 degrees to get a nice chemical reaction happening there. I'm floating in the low 80s at the moment, degrees Celsius that is, and it's working really nice. So yeah, I'll be back a little bit later when there's something of interest to show or tell. Okay, so now we're back on day 2. I have reheated my gold bearing solution there, and as you can see, there is no reaction currently happening there. The problem we have now when we're doing this is one of two things has been exhausted. Either the nitric acid has been exhausted, and I've only put about 1 milliliter or so of nitric acid in so far, or the gold in the solution has been exhausted. What we want is we want the gold in the solution to be all dissolved up. So the question then becomes, how do you know which one of the two? If you can't actually see the gold, how do you know which one of those two things is what's happening? And how we are going to deal with that is, hopefully this is going to be visible to you guys, but I have some little gold buttons there, a few grams worth, and what I'm going to do is I'm just going to very quickly drop one of the two buttons in there, close to the side hopefully, and you should be able to see it there on your screen. And as you will see, now this is really cool because it's doing exactly what we want to see. See that? You can see there's still a little bit of a reaction happening there. It's actually a relatively vigorous reaction, which is a little bit disappointing because it means there's probably still a fair bit of nitric acid in there. So what we will do now is we will pull out the little gold button there, because we don't want to put too much excess gold into this solution, because I actually want to measure the amount of gold to see how much we get out of those chips. And we're going to go through the evaporation and hydrochloric acid addition that we're used to. So yeah, I will be back with you guys in a couple of minutes when I have got the gold out of there, cleaned it off of any solution, and then transferred that solution to an evaporation dish. Okay, back soon. Okay, and as per my previous videos for evaporation, I like these big 2 liter, 2 quart Pyrex dishes that they're the kitchen type, so they're not going to be borosilicate, they're just going to be like stress relieved glass, but they work just fine. I have never broken one during normal, any kind of normal things that you would do with them. You wouldn't want to get them a few hundred degrees hot and then dump them into cold water. They will certainly shatter, but I think just about anything will. So yeah, what I'm going to do now is I'm just going to let this evaporate down at about, in the 80 to 90 degree temperature, the Celsius temperature range. When it gets down to only just a little bit of syrupy stuff in the bottom of the container, I'm going to add some hydrochloric acid, which is going to then get rid of most of the nitric acid that's still in there. One of the steps that I skipped in a previous video, which I will definitely be doing now, is just add a few drops of sulfuric acid to the mix there. What that does is it just it helps speed up the removal of the nitric acid, but it also helps precipitate out any dissolved lead, which we don't want in our final gold button. So yeah, so I'll be doing that now. So add a little bit of sulfuric acid, let that evaporate down to a syrup, add some hydrochloric, and then I will be back to show you the little trick that I do after I've done one evaporation. That is not a terribly large amount of liquid to evaporate. We're probably in the 200 milliliter range. The main problem actually is that I started off with about 100 milliliters of boiling water at the start, which I probably could have skipped and just taken a bit of time and warmed up the hydrochloric acid. But it is what it is now. So yeah, we'll just leave that, and I'll be back a little bit later. Okay, so the solution evaporating here has gone about as far as I personally like to let it go. Some people might pay more attention and let it go a little bit further, but that's my level of comfort. It's starting to kind of get a little bit more viscous, so we're going to add a little bit of hydrochloric. You don't need to add a lot, just a little bit here, just like that. See, there's a little bit of bubbling, which is the nitric going out. There we go. Okay, now the next little secret I've got is, once I have done one evaporation and refill with hydrochloric like that, what I like to do is grab those little gold buttons that I have, and the two that I have at the moment are 5.12 grams. I'm just weighing them off camera. I'm just going to give them a second weigh to confirm. Yep, 5.1 grams. And what I'm going to do is I'm going to drop those two little buttons into the solution at this point. The reason being, there's not really much point carrying on with this evaporation drama if there's no reaction there. So we're just going to make sure that all gets up to about 80 degrees or so, and then I'm just going to leave those gold buttons in there, and if there is, you know, a little bit of nitric left at this point in that solution, it will use itself up, or it will deplete the nitric by dissolving those gold buttons into the same solution. And all I have to do then is just use one of my lamps like this, nice bright. Just keep an eye on those two gold buttons, and when the reaction around them stops, I know that all the nitric acid has been used up in there. In the meantime, it's still evaporating off, so I'm kind of using two systems at the same time to get rid of that nitric acid quickly without having to spend a lot of time evaporating off solutions. Okay, I will be back once there is no more reaction there and I know that all the nitric acid has been depleted. Okay, so a little bit anticlimactically, I don't know if you guys are going to be able to see this very well, but it's only been a couple of minutes and I've let this solution get up to 80 degrees Celsius again, and there is absolutely no reaction at all, no bubbles forming on those two gold buttons in the solution, which means that we have got rid of enough of the nitric for the precipitation to work. So at this point, what I am going to do is I am going to add, I've turned off the heat, I am going to add about 6 or so ice blocks to that solution to cool it all down. I'll turn off the heat, we'll add 6 or so ice blocks to that solution to cool it down, and then I'm going to filter what's left in there into a clean beaker. So I'll be back in a minute. Okay, so time has come to, I've added the ice, it's mostly melted. The temperature of the solution is down to about 10 degrees Celsius, and there's still a little bit of solid ice, I guess, in there, solid water. And so I'm just going to slowly filter the solution now. I'm filtering through 2 coffee filters that have obviously been wetted down already. And the color of the solution is excellent, considering how dirty the material was that this solution came from. I am quite convinced that we have got mostly precious metals now in the solution, just going by the color of it. Okay, so here we have our solution after it's been filtered. In a small 100 milliliter beaker, I have got 2 grams of sodium metabisulfite, and what I'm going to do right now is I'm going to add about 80 milliliters or so of boiling distilled water to that, and in the background you'll hear me mixing and just breaking up any little clumpy bits of that. Mix, 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 mix. Okay, that's looking good. And now what we're going to do now, obviously, is we're going to add the sodium metabisulfite to our solution to precipitate out the gold. So we're just going to give our solution a tiny little bit of energy, a little bit of motion there, and hopefully this works, because otherwise this video probably won't be out in time. But what we expect to see is what I normally see is the solution goes clear, and then after a few seconds it turns brown as the gold precipitates out. So let's just see what happens this time round. So yes, I think you guys can see the color change in the solution. Yep, so we're going kind of quite clear there, and there might not be enough gold in there to actually make it go very much brown, because we're only expecting in the 0.2 to 0.5 gram type range. But what I will do is I'll just give it a mix now. And there you go, perfect. I was kind of hoping that would happen. It's always very nice when things work the way that they're supposed to. Sorry about the reflections there. I'm just going to spray down my my little thermometer here, because that might still have a little bit of gold solution on it, obviously. And put the watch glass back on top to make sure we don't get any contaminants falling in there. But apart from the lighting not being great, that was pretty much a textbook gold drop. That's exactly what I was expecting to happen all along. And so what we're going to do now is, this thing is just going to stand there for probably 12 hours or so. I usually leave them overnight, but at the moment it's midday here, so probably, maybe we'll see how it looks. Maybe late tonight I will show you the settled gold, otherwise tomorrow morning. Hey guys, so about a day has gone past for me, but only a few moments for you guys. And as you can see there, we have all of the gold powder very nicely settled to the bottom of the container. There's not very much, but then we've always only really been expecting point something of a gram, so we weren't expecting very much. I have now come to the point where we've basically got the gold powder there. I'm going to decant very slowly and carefully the solution from the gold powder into a secondary dropping container or secondary settling container, and then leave that for another half a day or so in the secondary settling container before it goes from the secondary settling container to the evaporation container, and then eventually to the stock pot. But yeah, this is probably as good a place as any to end this part of the process. Obviously there's now going to be a bit of washing of the powder, and with water and then with hydrochloric acid, and then there's going to be drying of the powder. What I'll do is just come back at the end of the video quickly to show you guys the weighing up of the powder, and just see if we roughly get what we're expecting, which would be really useful, considering it wouldn't be a very good process if we didn't get the gold we were expecting. But yeah, I'll be back a little bit later with the weighing. Okay guys, so after all of that work, here we have the resulting washed and dried gold powder. This has only been obviously through a single refine, but I have had quite good luck with my single refining. I'm getting very good enough purity with the single refine. So I thought what we'll do at this point is we'll just give it a weigh up. This is my temporary gold. There's already quite a few grams in there. These days I don't really bother to do any melting until I get to about 10 grams or so. So let's zero off the scale there. Now, I was hoping for 0.2 to 0.5 grams. I am thinking at this stage that I might be closer to the 0.2 side than the 0.5 side, but it's quite hard to tell with this powder, so let's pour it in and have a look. Okay, so I couldn't have I couldn't have planned that any better if I tried. Looks like about half a gram there. So half a gram of gold, scale just turned off, half a gram of gold from roughly 500 grams of mixed ICs is pretty much spot on with what we expected. So I really can't believe, it didn't look like that much, but the scale doesn't lie in the end. Very happy with that result, and yeah, I hope you guys enjoyed this video, and I've got a couple more interesting things coming, so stay tuned.